Okay, so as so often happens in this class, we're in the middle of a long problem. So we had left off last time having to do these two integrals. So let's just knock this one out real quick. I'm going to do a very quick u sub. I'm going to let u equal 2 theta so that du is 2 d theta. Now that means I'm going to introduce a 2 counterbalanced by a 1/2. If I wanted to, I could have split this up into two integrals, and then I already have the 2 for this piece. But I've chosen to keep it as one integral, and I didn't have a 2 in that term. So I do need to introduce that 2 counterbalanced with the 1/2. So this is going to give me 1/96, the integral. Now it's from 0 to 2 pi, because I'm switching to my u values. And then it's just 1 minus 2 cosine u du. So that's going to give me 1/96 of u minus 2 sine u evaluated between 2 pi and 0. So that's 1/96 of, at 2 pi, I get 2 pi minus 0, and at 0, I just get 0. So it's a 96th of 2 pi. That's going to be pi over 48. I've got to add to that this integral. Now here, I'm going to have to use the double angle formula for cosine again. Now, if you know what that is, you don't need to derive it. If you think you know what it is but you're not sure, I would encourage you to derive it. And if you don't remember, you should derive it. So remember, cosine of 2 theta is cosine squared theta minus sine squared theta. This time I want to keep the cosines and get rid of the sines. So I'll say this is cosine squared theta minus 1 minus cosine squared theta. If I distribute the negative, that makes this a plus cosine squared theta. So I get 2 cosine squared theta minus 1. That was still equal to cosine 2 theta. So I'm going to add over the 1 and divide by 2. So cosine squared theta is cosine 2 theta plus 1 all over 2. So with that work, this integral here becomes 1/48, the integral from 0 to 2 pi, of cosine of 2 theta plus 1 over 2. I think I'm just going to factor out that 2 in the denominator and make that 1/96, and then we're integrating that d theta. So again, quick u sub, u is going to equal 2 theta, so du is 2 d theta. So I must introduce a 2, which I will counterbalance with a 1/2. So let's see, that's going to be 1/2 times 1/96 integral from 0, now it's to 4 pi of cosine of u plus 1 du. I'm not bothering to multiply this out because I'm anticipating I'm going to be able to do some canceling. So that's 1/2 times 1/96. I'm going to get sine u plus u evaluated between 4 pi and 0. I need some space. So, evaluated between 4 pi and 0. So I'm going to bump up here. 1/2 times 1/96 of, when I plug in 4 pi, sine of 4 pi is 0 plus 4 pi, minus, when I plug in 0, I just get 0 plus 0. So I can cancel. I can cancel a 4. That's going to go into the 2, cancel with the 2, and reduce that back down to a 48. So this is going to give me pi over 48. Now, that was this integral here. I need to add that to this integral here. So we've got pi over 48 from the first integral, plus another pi over 48 from the second integral. That is 2 pi over 48, which is pi over 24. And we're done. I am very happy that that is a positive number, because we were finding volume. Now, if you're just doing a triple integral so that you're finding signed hypervolume, signed hypervolume can be signed. If you're integrating 1 to find geometric volume, that does need to be a positive number. If it's not, you made a mistake, go back and try to find it. Do not just assume that you got the opposite of the correct answer and change the sign. That's making an assumption, which is your second mistake, and I will dock you for both. If on an exam you had a negative answer and you can't find your mistake, remember what you do is you write me a note. Dear Carla, I know volume isn't negative. This makes me sad because I know this is the wrong answer, but I'm not going to commit a second mistake by submitting a negative answer as if it's reasonable, or by assuming that I just got the opposite of the correct answer and changing the sign. At least you'll only dock me the 1 point, not 2. Sincerely, your name. Okay, excellent.